Good evening, everybody. This is Omar Daoud, one of the authors for the work entitled V2V Better Enhancements based on fast frequency hopping OFDM. This work is a result for a collaboration work between Philadelphia University of Jordan and the American University in the Emirates. In this work, uh, I'll talk about uh, uh, I'll talk about introducing the main idea, the motivation, system design, results, and discussions. I'll go to the drawn conclusions and for some recommendations and future work. As an introduction, the proposition for the V2V communication enhancements based on clustering techniques. So in order to remedy the real-time data reliability issues, the research based on hybrid between the VANET and the LTE systems has been proposed. This proposition is divided into two main parts. A proposed clustering algorithm compared to the literature based on a clustering weighting factor, in addition to multi-parallel processing for enhancing the quality of service, making use of debouches, wavelet baby functions. After that, as a result of this combination, any moving nodes will have the capability to access the internet by making use of the LTE network infrastructure, as well as the privilege of enhancing the VANET system performance will be attained. To realize such combination, we need to thought about the OFDM. The OFDM model has been imposed, which led to enhance the quality of service based on high-speed communication and low delay time. Furthermore, the multi-band OFDM techniques is a very promising candidate for over 100 megabit per second download connections. OFDM has a robust behavior against the different severe effects of the channel, especially the dispersive ones. Therefore, this work will offer saving in the impaired channel due to the intersymbol interference, as well as it will save and reduce the consumed power by managing the channel resources. The motivation behind this work describes the performance enhancement for the V2V communication based on LTE systems. This proposition is based on making use of the fast frequency hopping orthogonal frequency division multiplexing, in addition to the multi-parallel antennas or the MIMO technology. As shown in this figure, in figure 1, it will show the communication between the V2V nodes or vehicles communicating to each other through their clusters head via the LTE infrastructure. So we will try to mitigate the Doppler spread effect on the V2V clustering benchmark, which contains a clustering weighting factor based on based stage and a multi-parallel processing stage. This work will reuse the spatial resources by reclustering the huge number of mobile nodes. The reclustering process is done by making use of the relative speed, maximum communication range, adaptive factor, and the clustering weighting factor. The adaptive factor and the clustering weighting factor has been described clearly in the manuscript. Thus, the scope of this work is limited to a single hub clustering V2V architecture. As a result of this part, the head of the clusters is shown adaptively under the concern of the acceptable added overhead from updating the cluster's head. To cope with this proposition, a part of using the fast frequency hopping has been imposed into the physical layer for the OFDM stage, as shown here by the CNI block, as a pre-coder stage. A pre-coder stage contains the fast frequency hopping OFDM is considered as an enhancement stage for this benchmark. The OFDM modified or the new physical layer for the OFDM for each hop can deal with both of different channels and different sets of spread signals as depicted in figure 2. The system design, the OFDM is one of the main techniques that have been proposed in order to facilitate the usage of the wireless cellular systems. It has been easily described and created by implementing or proposing the inverse fast Fourier transform. As said before, the OFDM is a good proposition for the over 100 megabit per second for the download communication and over 30 megabit per second for the uplink communication. In this flow chart shows, we can show the criteria for clustering and choosing the cluster heads based on, as I said previously, clustering weighting factor and some parameters related to the positions and the speed or relative velocity and the relative speed and the communication range. The novelty behind using this stage is to deal with the communications link of the cluster's head as shown previously or as depicted previously in figure 1. This step will enhance the data rate and the velocity for the communication between the vehicles themselves and the vehicles themselves through the LTE infrastructure. This step will enhance the data rate as said before. It might be processed with making use of different Dirichlet's wavelet kind and a special level as defined in our previously published work, as found in references 21 and 29. Moreover, the OFDM indicators reconstruction performance is checked primarily based on subsequent indices, such as the maximum absolute value, the correlation matrix, and the relative error. Furthermore, another performance criterion is based on the CCDF has been used to check the peak to average power ratio that could be facing the combining signals based on the OFDM. And this performance criterion, the enhancement checked based on the new generated signal peak to average power ratio new values. For the results and the discussions, the proposed work has been verified based on the comparison with the conventional OFDM structure. This is in addition to compare the attained results from the modified benchmark that related to clustering techniques. Two simulation environments have been used in NS3 simulators and MATLAB. A simulated environment has been built to examine the benchmark mathematically. The detailed simulation environment contains the followings: relay fading channel, QPSK modulated techniques, 184 OFDM subcarriers, the symbol intervals, the two lanes crossroads, the vehicle speed, the vehicle transmission range, number of trials for choosing the optimum values, two antennas using zero forcing and minimum mean square error equalizations, Doppler shifts of 30 Hertz. In figure 4, the bit error rate is the main concern in order to check the system performance. This figure depicts the bit error rate results obtained from the simulators at two different speeds, 70 kilometer and 100 kilometer per hour. From the depicted results, the fast frequency hopping OFDM shows an interesting and better performance over our conventional work in the previous published references. The performance is enhanced somehow at the 30 Hertz Doppler effect when increasing the signal noise ratio. At a signal noise ratio of 8 dB, the bit error rate performance has been enhanced from the 3% for the conventional fast frequency hopping based on our previous work to more than 5 times 10 to the minus 5 of the used scenario for the 2x2 antennas and using the minimum mean square error 30 Hertz Doppler shift. Furthermore, in order to validating our proposition, the cluster head average lifetime performance has been checked based on two different parameters, the maximum speed and the vehicle transmission range. It concludes that the use of the fast frequency hopping OFDM enhances the benchmark performance and gives better results than the lowest ID-based results in our previously published work that has been considered in the literature as one of the best clustering techniques based on the ID for each vehicle. At a speed of 100 kilometers per hour, the cluster's head lifetime has been improved by almost 7%, which is almost the same results that has been attained in the literature for the lowest ID DCA work. As a drawn conclusion in the future work, the prevailing VANET technology can transfer information among moving cars with a proper reliability. However, they lack having an access to information communication. This proposition has been done in order to attain the advantage or to extract the advantages behind imposing the special multiplexing MIMO systems and enhancing our previously OFDM work. This paper shows the overall performance for of the V2V communication-based LTE systems, which has been investigated based on imposing MIMO technologies into the fast frequency hopping OFDM-based systems. The proposition has been investigated based on our published clustering architecture combined to multi-signal processing. From the depicted outcomes, exclusive parameters has been investigated so as to check out our proposition, specifically bit rate and the cluster head existence and lifetime. We have proposed the size of MIMO structures of 2x2 with zero forcing equalization. Also, Doppler shifts values were considered to be 30 Hertz. At a speed of 100 km per hour, the cluster head lifetime has been improved by the ratio of, as we said previously, 7%. At signal to noise ratio of 8 dB, the bit rate performance has been enhanced from 3% to almost 5 times 10 to the power minus 5 of the used scenario 2x2 antennas, 30 Hertz Doppler shift. Thank you very much. Thank you for your listening.